Okay, so let's see. A uniform cylinder with a round surface and of radius A is fixed with its axis horizontal. So this is the cross-sectional area of the cylinder. Two identical uniform rod AB. So this is AB, one of the rod, and BC, the second rod, each of weight W and length 2L, are rigidly joined at B. So that means they're joined up here, fixed. Okay, cannot move on. So it's not flexible, it's always 90 degrees, in other words. With AB perpendicular to BC. The rod rests on the cylinder in a vertical plane, perpendicular to the axis of the cylinder. Okay, so that means like this. Okay, right on a flat surface. Okay, then after that, with AB at an angle theta to the horizontal, which is like this. D and E are the midpoints of AB. So D is the midpoint of AB and BC. So this is also the midpoint of BC, respectively, and also the point of contact of the rod with the cylinder. So it's the midpoint, and at the same time, it is the point of contact. And okay, the rods are about to slip in a clockwise direction. Clockwise direction. Okay, so that means it's going to move this way, clockwise direction. So this is the motions. It's going to move this way. So of course friction is going to be opposite. The coefficient of frictions between each rod and the cylinder is mu. It's mu. So because the motion is this way and the friction is the opposite way. So the frictions, let's say here, it will act this way. This is the frictions. I call it F frictions at point E. Friction at point E is acting opposing the motions. The motion is clockwise. So likewise here, the frictions is acting this way. So I call it force of the frictions, or frictional force at point D. At point D. The friction is in that way. And the normal reactions between AB and the cylinder is R. So that means this is going to be R. R is going to act this way. And the normal reaction between BC and the cylinder is N. So N is going to act this way. And of course, because of this, right, we have the coefficient of friction. So we managed to form an equation, FFE equal to mu N. And then the FFD equal to mu R. FD equal to R. Okay, managed to form the equation because of this information. Find the ratio R to N in terms of mu, where mu is the coefficient of friction. So we have to work on this first. Okay, so of course we already formed some equation. Let us write it down here. The first equation is the FFD. So I get mu R. The second equation is FFE. I get mu N. Okay. Then after this, we can use, they give information like about to sleep in the clockwise. Okay, so it is still in equilibrium, but it is about to rotate, about to move in circular. So we can use moment, for example. We can also use resultant force equal to 0. So because of this, whenever they say this, or whenever you see equilibrium, we can use resultant moment equal to 0. Resultant moment equal to 0. If you don't want this, you use clockwise moment equal to anti-clockwise moment. You can use this also. Then the second thing is the resultant force. Resultant force equal to 0. So these are the two concepts that we can use. So we have to make use of this and form equations, and then from there we just do some simultaneous. Okay. Now let's say I start with moment first. So for moment, let's say the motion is like this, and let's see the force that act on the cylinder. Okay, so we have I just put all the force. We have W. W is the uniform rod AB. W should act downward. W act downward. And then BC also have the weight of W because there's an each of weight W. So here weight acting downward, W also. Okay. Now this is the force because of the rod, and then we have R. We also have N. We also have frictional force. Okay. So now what we need to focus is we focus on the two rods here. We don't focus on the cylinder. It seems like the information on the cylinder is not that enough. So we focus on the rod. Forces acting on the rod only. Which are the one that I label in the diagram? W, N, and then friction, W, R, friction. Okay, so I make use of this, and I need to form the equation involving moments. Okay, so I use clockwise moment equal to anti-clockwise moment, let's say. Okay, so I need to set a center. Let's say I set moment about the rotation is this way. So it seems like this is good enough to be the center. So rotation about the center of cylinder. Okay. So let's set up first which one is clockwise and which one is anti-clockwise. Okay, so I have this as the center. This one is going to be this way, and this way is anti-clockwise. This one is clockwise. This one no need, no need. Okay, let's say I use different color. Okay, so I use blue color for the moment part. This is clockwise. No, this is anti-clockwise. Is it clockwise? This one no need, because this n has no perpendicular distance with the center of cylinder, so no need. And the frictional force, let's say I put in a more proper position, which is here. Frictional force is acting this way. This is center of clock is there, anti-clockwise. Okay, anti-clockwise. This one, okay, again I put in a more proper position, so it should act along the rod. So this one, this is hence anti-clockwise. Yeah, so center is here, anti-clockwise. Okay, so I need to form the equation based on the moment. I have to look at the diagram at the same time. Okay, so let's say I put those clockwise moments on the left. So clockwise moments, I have only one, which is this one. And I need to find the perpendicular distance to the center of the cylinder. Okay, so which means to find the distance, I need to, okay, I have this horizontal theta over there. And because of that, if I add one line, this theta is going to be here also. It's going to be here. Okay, so yeah, theta is going to be there. And I can find this one. This is the distance required, the perpendicular distance, by using A cos theta. A cos theta. So because of that, I have W multiplied with the perpendicular distance. So W times A cos theta. Okay, so this one settle the clockwise. The rest are anti-clockwise. So for anti-clockwise, let's say I start with this. I have the FE, the mu n, multiply with the perpendicular distance. This perpendicular distance is just A. A. So this is perpendicular. Multiply with A. So this is quite direct. And then I have the second anti-clockwise moments at this point. So which is the mu r. And the perpendicular distance is this one, A also. So mu r multiply with A. Then I also have the third anti-clockwise moment, which is the W here. W. And I need the perpendicular distance, which is here. So I have to make use of the information here, which is A at this triangle, to find out this distance, the perpendicular distance. So that perpendicular distance is, as you see, this is theta here. Theta is here. So you need to think by transferring the angle one by one. So at the end, theta will be here. So this is A cos theta. This one is A sin theta. So here is A sin theta. The W is the force. Perpendicular distance is A sin theta. So we managed to form an equation in this way. Now let's simplify this. So I'm going to gather up the term with W. This one and the one, I put them on one side. Factorize WA. Cos theta minus sin theta. And then for these two, I put together. And at the same time, let's say I factorize A mu. Then I get N plus R. Then I cut the A on both sides. So I get W cos theta minus sin theta equal to mu n plus r. Okay, then I just leave it like this first. I call it equation 1. Okay, now let's consider, we have considered the moment. Let's consider resultant force equal to 0. Resultant force, okay, so our force is acting on the rod only. So let's see on the rod, on these two rods. These two rods considered as one set. Okay, so the force we have N. Okay, so let's say I follow a particular direction. I follow AB first. So force acting in resultant force along AB is equal to 0. Resultant force equal to 0. So which is this direction? Same direction with this one, AB. Okay. Now let's see the force acting this way consider positive. Acting in the direction of AB consider positive. So this is positive. And the N is positive. Then we need to resolve that. Okay, so I have to resolve the W so that I have this direction, AB direction. So which is going to be like this and like that. And then theta is going to be up here. So hence this is W cos theta acting backwards. So opposite, W sin theta. W sin theta. Since this is opposite, so I call it W sin theta. So which is minus W sin theta. Okay, now let's consider this one, the weight here. So I need to resolve it, and this way and this way. This is down, this is here. Okay, this is opposite of the theta. So again, this is W sin theta, and this is going down against AB. So this should be minus W sin theta. And then the other force, mu r, against AB also, minus mu r. Of course, this r ignore because it's perpendicular to AB. This one also perpendicular to AB. We can just ignore straight away. There is no component along AB. Okay, so equal to 0. So we get the second equation. And let's simplify this. I put these two together, 2W sin theta, 2W sin theta on one side, and N minus mu r on the other side. And then we have W sin theta equal to 1 over 2 N minus mu r. So we have this, and let's say I call it equation 2. Equation 2. So what we want is the ratio of r to n. So it seems like we need to get rid of the W sin theta. Okay, so then we are able to do it. Okay. Now let's consider also resultant force along CB. Okay, so resultant force along CB equal equal to 0. Okay, so I take this direction as the positive direction. Okay, let's see the force. So I have the mu n. Mu n is positive. Mu n. Then what else? I also have R. R is positive. Then I have this one. This one is W cos theta. W cos theta is negative. This one is also W cos theta. So I have these two which are negative. So I put here W cos theta minus W cos theta. So equal to 0. And then I arrange it. These two I put together. 2W cos theta. And then these two will be mu n plus R. So I have W cos theta equal to 1/2 mu n plus R. So let's say I call it equation 3. So you see, we want to answer the question in this way, R to n. So we need to get rid of the trigonometry, the cos and sine theta, as well as the W. We need to get rid of that. We will make use of equation 1, 2, and 3 to do that. So what we can see here is I can substitute W sine theta here. I can substitute W cos theta here. So I substitute 2 and 3. 2 and 3 into 1. Okay, so first I have W cos theta replaced by 1/2 mu n plus R. Then if you see here, expand it and imagine that I have W sine theta, which take negative sign. So negative W sine theta, okay, which is this one, 1/2 n minus mu R equal to right hand side mu n plus R. Okay, then after that, I expand it. 1/2 mu n, 1/2 R, 1/2 n, 1/2 mu R, mu n, and mu R. Okay, then I have to put together all the information. So I have half mu n, okay, I put here half mu n, mu R, bring over half mu R. Then on this side I have only half R minus half n. Okay, so what we want is R to n. R to n. Okay, so I have to put together the R terms. So I shift the R terms to the left. I shift the n terms to the right. 1/2 n plus half n. Okay, then let's say I times 2 first. There are so many half over there. So R minus mu R mu n plus n, factorize 1 minus mu 1 plus mu. Okay, then divide R divided by n is 1 plus mu 1 minus mu. Then we get the ratio R to n, 1 plus mu ratio to 1 minus mu. So we get this. So that is part A. So part A, we managed to get the ratio. Now let's see part 2, part B. Given that mu equal to 1 over 3, find the value of tangent theta. Tangent theta. Okay, so when you get mu equal to 1 over 3, it will help us to work out the ratio between R to N. Ratio between R to N. So we put inside and work it out first. So when mu equal to 1 over 3, R to N is 1 plus 1 over 3, ratio to 1 minus 1 over 3. So which is going to be 4 over 3 and 2 over 3. Simplify the ratio, I will get 2 to 1. Where R divided by N is 2 divided by 1. So R equal to 2N. So at least I get this relationship. And now we want tangent theta. So we know that we have sine and cos. We have to divide them to get tangent. So I take equation 2 divided by 3, which is this over this. Then I get tangent theta on the left. On the right, I just take this and divide by this. I'm going to get n minus mu r over mu n plus r. So I get this now. And I know r equal to 2n, unless I call this equation 4. So I'm going to substitute equation 4. So tangent theta n. So whenever I see r, I replace with 2n. N minus mu 2n. Then mu n plus 2n. Then I remove the n. Let's say I factorize first. And I cut away the n. Then I know mu is 1 over 3, I substitute inside. So 1 minus 2 over 3 over 1 over 3 plus 2. So I get 1 over 3 over 7 over 3. So which is 1 over 7 at the end. So like that. Okay, so I managed to solve the whole question. Any question or not for this?
Wait, can you scroll down to the second part?
Okay, yes.
Okay.
You see, again, this is two objects. One is the first object is the rods. The second object is the cylinder. So when we solve, right, we don't care about the cylinder. We don't care about the forces acting on the cylinder. We just care about the forces acting on the rods. So then the equation are based on that also.